Hi students, welcome to the session on Enfire Array. In this session we analyze Enfire Array and the meaning and when the radiation is maximum in Enfire Array and where we get minors and nulls, right? Let us start. So Enfire Array, first we must know what is Enfire Array, EFA, right? So Enfire Array is an array in which maximum radiation or main beam occurs along the axis of array, right? So if it is array axis, right, so the maximum radiation occurs along the axis of the array like this, right? So the theta value is 0 degree or 180 degree. So the maximum radiation occurs at theta is equal to 0 or 180, right? And similarly, we know that for maximum radiation to occur, psi is equal to 0. Fine. This indicates array factor is given by psi is equal to beta d cos theta plus alpha. For maximum radiation, psi 0. For Enfire array, theta is equal to 0. Theta 0 means it is beta d cos 0 1 plus alpha. This indicates alpha is equal to minus beta d. Right? So for Enfire array, what are the three important characteristics? Enfire array means we must know theta is equal to 0 degree, psi 0, alpha progressive phase shift is minus beta d. Beta is equal to 2 pi by lambda, that we know. Fine. So this is what the primary parameters to be understood in the Enfire array. Now we derive the equation. First we find a beam width between first null for Enfire array. We know that the normalized electric field is given by sine n psi by 2 divided by sine psi by 2. If you have any doubt, please refer video on uniform linear array. Right? So I want to find null. Right? So nulls occur at, you see, E must be 0 for null. Null means electric field is 0. So that is possible only if n psi pi by 2 is equal to k pi, because n psi by 2 equal to plus or minus k pi, where k is 1, 2, 3, etc. Why? When k is equal to 1 pi, so n psi pi by 2 is pi means sin pi 0, so E 0, null. 2 means 2 pi, so sin 2 pi 0. So that's what nulls occurs at n psi pi by 2 is equal to k pi. First, let us assume first null occurs at k is equal to 1. This implies psi is equal to psi 1. That's what first null. K is equal to 1 means pi, 2 pi, I bring n this side. Plus or minus, we take only minus. Why we take minus? In order for convenient of analysis, right? So we take minus only for convenience of analysis. You can take plus also, it is tedious process, right? So we take minus, right? Okay, so first null occurs, and we know, see, for first null will also, I can write psi 1 first null as beta d cos del phi minus beta d, right? Cos del phi minus beta d. Why I am writing like this? Here you see our nulls occurs, maximum radiation occurs along the direction of array axis, right? So it is the direction of maximum radiation means 0 degree. Clear? This is 0 degree. So the nulls may be occurring anywhere, somewhere here or here somewhere. Clear? So that means it is away from that. That distance or angle is, let me write del theta, not del phi. I write as del theta because we use the term theta only. So del theta. Here only the null should have occurred. Or this side, this is del theta, right? So that is what I am writing. So first null occurs at beta d cos theta. Alpha is equal to minus beta d because we know psi is equal to beta d cos theta plus alpha. For Enfire array, alpha is equal to minus beta d. Just now only we derived. Yes or no? So alpha is equal to minus beta d. I substitute alpha is equal to minus beta d. Null occurs at some del theta, not theta. So this is the location of null. So already first null location I have found. I equate both. Right? So I write here. This is better. 1 is equation number 2. This is equation number 3. This is equation number 4. 3 and 4 are same only. Right? Both are talking about first null. So minus psi 1 is equal to 2 pi by n. 3 and 4. Psi 1. Instead of psi 1 substitute minus 2 pi by n. That is equal to beta d cos del theta minus beta d. Right? So that will give beta d cos del theta minus 1. But we know that cos del theta is equal to approximately 1 because del theta is very, very small. For small value, for example, cos 0, 1. For small value, the value of cos is very, very, equivalent to 1. 1 minus, so this and all will not be going to cos theta equal to 1 minus del square. Okay, I write the equation properly. Otherwise, I write cos del theta is equal to 1 minus del theta square by 2 factorial plus del theta power 4 by 4 factorial. I can go, right? So we take up to 2 value. So for small del theta, cos del theta is equal to 1 minus del square del theta square divided by 2 factorial, right? For example, it is 0.8 means 0.8 square is 0.64. 0.8 power 4 means it will be very, very less. That is divided by big value, the value will become negligible. Yes or no? You see, for example, del theta 0.8 you assume. So 0.8 square divided by 2 plus 0.8 power 4 divided by 4 into 3 into 2. So this is very, very small. So I stop with this 2 factors. Right now I substitute cos theta value here and equate it. So minus 2 pi by n is equal to beta d. Instead of cos theta, 1 minus del theta squared by 2 factorial minus 1, that is equal to minus del theta squared by 2 beta d. Right? So this indicates del theta squared is equal to 4 pi by n beta d. Beta is equal to 2 pi by lambda. 4 pi by n into 2 pi by lambda into d. This indicates del theta is equal to 2 lambda by nd. What about our beam width? Beam width is equal to 2 into del theta, that we know. Yes or no? Why? If it is a radiation, this is the first null, this is the second null. Beam width means this is del theta, this is del theta. So total is beam width. So 2 del theta. So 2 into 2 root 2 lambda by nd, that is equal to 2 into 2 lambda by L. So nd is equal to L. Why nd is equal to L? Please refer my video on broadside array. So beam width between first null for Enfire array is given by, beam width between first null is given by 2 into 2 lambda by L. Radian, please remember. Right? If it is degree, multiply by 57.13, so it is 114.6, 2 lambda by L degree. Beamwidth between first null. Right, now we find direction of local maxima or side lobe maxima. We know main lobe occurs at theta is equal to 0 degree. Where is the side lobe occurs? So as usual, we start with the uniform linear array. E is equal to sine n psi by 2 divided by sine psi by 2. Right? Sine lobe maxima occurs at side lobe maxima occurs at, again you see, this must be equal to in terms of pi by 2, sine pi by 2 1, 3 pi by 2, like that. So n psi by 2 is equal to pi by 2, right? For in general it is 2k plus 1 pi by 2. We just remove this. Generally we write, what is this? So this indicates psi is equal to plus or minus 2k plus or minus 2k plus 1 pi by 2 divided by n. Clear? So this is what side lobe direction of local maxima we find. So for Enfire array we know alpha is equal to minus beta d, right? So what I want is psi is equal to beta d cos theta maximum, side lobe maximum, right? Minor, right? Plus alpha is equal to, that's what psi is equal to beta d cos theta plus alpha. Alpha I write as minus beta d is equal to plus or minus 2k plus 1 divided by n pi by 2. If you simplify, I take theta max minimum minor lobe or side lobe is equal to, what will happen? I bring everything that side, so minimize it. So it will give cos inverse plus or minus 2k plus 1 divided by beta d n pi plus 1. Okay, so this is what minor lobe maximum. So for example, I take n is equal to 4 element array and the elements are separated by a distance of lambda by 2, and the progressive phase shift is alpha is equal to minus pi. Fine. So what will happen? Theta max, I substitute those values here. Minor is equal to cos inverse. Take, just for example, you can take anything, right? Cos inverse plus or minus 2k 2. I go for k is equal to 1. 2 plus 1 pi beta 2 pi by lambda d is equal to lambda by 2, n is equal to 4 plus 1, right? Okay, so what will happen? I think here it is it will be like this, right? So if you simplify, what you get is cos inverse plus or minus 3 by 4 plus 1. So it indicates cos inverse minus 3 by 4 means it will be 1 by 4. If I take plus 3 by 4, it will be 7 by 4, right? Okay, but cos will not go beyond 1. So this is not possible because 7 by 4 is greater than 1. So cos will be less than 1. So cos inverse of 1 by 4. This implies theta max minimum. Cos inverse 1 by 4 is 75.5 degree, right? Similarly, theta max minor, another value is theta max minor, same condition except k is equal to 2. If I substitute k is equal to 2, what I get is cos inverse plus or minus 5 by 4 plus 1. Right here. Same condition I take except k is equal to 1 here. I substitute k is equal to 2 in the same equation. What I get is plus or minus 5 by 4 plus 1. So that will give cos inverse 9 by 4 or cos inverse minus 1 by 4. If I take 5 by 4, 1 plus 5 by 4 is 9 by 4. If I take minus 5 by 4, it is minus 1 by 4. Again, cos cannot be greater than 1. 9 by 4 is greater than 1, so it is not possible. Only this is possible. So cos inverse minus 1 by 4, that is equal to 104.5 degree. So direction of minor lobe maximum is 104.5 degree. Already we have one minor lobe maximum at 75.5 degree. So we have two minor lobes maximum. So similarly, direction of side lobe minima, direction of minor lobe minima, direction of minor lobe minima, right? Follow the same procedure. Maxima, it should be pi. Here psi is okay, sin n psi by 2 divided by sin psi by 2 e. So this implies minima occurs at when sin n psi by 2 is equal to k pi. Yes or no? Because sin pi is 0, sin 2 pi is 0. So n psi by 2 is equal to plus or minus k pi, where k is equal to 1, 2 or 2. When k is equal to 1, sin pi, so n psi by 2 is equal to pi means sin pi 0. So minimum will occur. 2 pi sin 2 pi 0. So minimum will occur. So this indicates n psi by 2 is equal to plus or minus k pi. This implies psi is equal to plus or minus 2k by n. Psi we know beta d cos theta, minor lobe minimum. So minimum minor. Beta d cos theta alpha is equal to minus beta d. Right? So for what do you call? For Enfire array, alpha is equal to minus beta d 2k by n. Right? So if you simplify this equation, what happens is cos theta minimum, right, is equal to cos theta beta d I take outside minus 1 equal to plus or minus 2k pi divided by beta d. Beta is 2 pi by lambda into d into n. That is equal to plus or minus k lambda divided by nd. From this equation, take beta d outside and bring right hand side. Instead of beta, you substitute 2 pi by lambda into d. So this indicates, right, cos theta I write as 1 minus 2 sine squared theta minimum minor 1 minus 2 sine squared theta by 2 minus 1 is equal to plus or minus k lambda by nd. Right? If you simplify sin theta minimum by 2 is equal to plus or minus k lambda by 2nd. So from this we can get theta minimum for minor lobe. So this minor lobe only, minimum for minor lobe is equal to 2 sine inverse of plus or minus k lambda by 2nd. Right? So you see here, as usual, we take 4 elements. N is equal to 4, separated by distance lambda by 2. For k is equal to 1, theta minimum, minor lobe minimum, first minimum occurs at 2 sine inverse. Substitute all the values here, k value 1, lambda, n value, everything. If we substitute, what you get is plus or minus 1 by 2. That is equal to plus or minus 60. Here, similarly for theta minimum to, right? Here I substitute k is equal to 1, here I substitute k is equal to 2. 2 sine inverse plus or minus 1 by root 2 I get, this is k value, k. I get as plus or minus 90 degree. Similarly, theta minimum 3, I get 2 sine inverse. Rest of the values are same. N is equal to 4, d is equal to lambda by 2. Right? So what I get is plus or minus root 3 by 4. That is equal to plus or minus 120 degree. So what are the minimum? 6 minimum we have. 1, 2, 3, 4, 5, 6. So we have minimum at plus or minus 60, plus or minus 90, minor lobe minimum, plus or minus 120 degree. Right, now we draw the diagram, radiation pattern diagram. Okay, right, here you see antenna array axis. Right, we have 6 element and we know it's a Enfire array. Right, so maximum radiation occurs along the direction of antenna, so it will be like this. We know it is 0 and 180 degree. 0, 90, 180, 270. Right, minor lobe maximum occurs at, we know we have derived minor lobe maximum occurs at 70, 104.5, 75.5. So 75.5, 104.5. So we go there and draw 75.5. So this is what I draw properly. So this is what 75.5 degree. So here only the one minor lobe maximum occurs. And 104.5, 104.5 degree. This is where another minor lobe occurs. Right? Okay. Similarly, we will have minus 104 here and here. Right? So this is what the minor lobe maximum. Then we see minor lobe minimum plus 60 minus 60. So this is one minor lobe minimum, 60. This is minus 60 plus 90 minus 90. Here the minimum null, minus 90. This is minus 90 plus 120. This 90. This may be 120. Fine, there is minus 120. This is 0, minus 90. Here it may be minus 120. So 1, 2, 3, 4, 5, 6 minimum. Right? So this is what theta direction. Theta 0, theta 180 degree. Right? So in this way, we can conclude and draw the radiation pattern of Enfire array. I hope the analysis is very clear. If you have any doubt, please ask me in comment section. I will clarify. Thank you.